Hi, this is David from Apigee. Thank you for joining us today for this discussion on Droid Wars, protecting your APIs from cyber threats. And a little bit of housekeeping up front, if you want to.
Yeah, hi. This is Subra Kumaraswamy. I'm the Chief Security Architect and Head of Product Security for Apigee. This presentation is recorded and will be available on YouTube. You can go to youtube.com/Apigee to look at this presentation later on, as well as a lot of other rich presentations.
Right. All of our content's up on YouTube, and the slides later on, we'll upload those. They'll be on SlideShare, right? Great. So you just introduced yourself. Like I said, my name's David. I have led go-to-market for Apigee, a long time ago in a galaxy far, far away. Led telco go-to-market, and I'm now part of the data products team, leading go-to-market for our two data products, and we're going to talk about one of those data products today.
Awesome.
Great. So it's Black Friday is coming up, right? Which is a very important event for retailers, but another really important event for some of us that are into sci-fi movies is the new Star Wars film. That's coming out in mid-December. So we're going to have some fun with this today and talk about bots, which is why we call this the Droid Wars, and how that affects Black Friday and API security in general. Right? Now, there are good bots, right? There's good droids, right? Most obvious one, search engine indexing, right? And we all know about that.
Google bots.
Google bots, yeah, exactly, right? And those are the good guys. And health monitoring is another example of a good droid. In fact, we could do a commercial right now for Apigee API Health.
Yes. In fact, the API Health is a very good way to monitor APIs, and it's available for all our customers.
Yeah, absolutely. And the point of API Health, right, is you may have a machine that's green, it looks up, but is your API actually serving requests, and what's the customer experience, right? And so we've got a good bot of our own that helps us and helps our customers make sure that it's healthy and serving good responses. And then people also do performance testing and that kind of thing, right?
Right.
So there's plenty of examples of.
Yeah, especially what we're seeing is that a lot of the customers are using cloud services because the fact that you can get a lot of horsepower in a very short time, and of course they're all automated.
Yeah, absolutely. So those are good bots. That's not what this is about.
Exactly.
Right? So this webcast is really about bad bots, and there's lots of examples of bad bots, especially when you start thinking about critical days like Black Friday that are coming up. And so a lot of our retail customers, have pricing strategies and promotion strategies and other things that they're running during this time, and they could be targets for bots, right?
Yeah. Speaking of target, in terms of we talked about the Star Wars movie. The tickets got sold in 2 hours, and I'm sure there are bots out there, which got a lot of tickets, for.
I'll have to buy mine on eBay, I'm sure. Right, but that's so. When you think about, hey, could I be a target for a bot? Really, if you have, any kind of valuable content whatsoever, right? Whether it's, your pricing information, a lot of retailers now also allowing kind of buy online and pick up in store, and so they have inventory checks that they're exposing in their apps. So you've got inventory information that's being exposed. If you sell content, right, any kind of valuable premium content, essentially, lots of internet businesses are tied to data, and any kind of valuable data could be a
and pricing information is especially very sensitive information. Given the fact is that it's a differentiator and can impact your bottom line.
Yeah, and so scrapers are certainly one kind of bot. We put down reconnaissance bots.
Yeah.
Can you talk about reconnaissance?
Yeah, that's that's one of the things that we're seeing where the bots are hackers are getting very sophisticated, and obviously they don't want to be sitting in front of a terminal and hacking away. So there are bots that are programmed to come and look for a weakness. And probably folks are familiar with application security tools that you would deploy in front of your applications. Same thing right here. You've got bots trying to probe for weakness in your APIs, and you want to make sure that you have countermeasures against that. We'll talk about that.
Yeah, absolutely. And then the other one, brute force, is pretty popular.
Yes.
Popular bot.
Yeah, and that's again, the DDoS attacks happens in different layers. Specifically, what we're talking about here is really around bots programmed to target your API endpoints, as an example, right? Which is different. It's still a DDoS attack, but more of an app DDoS, and very targeted towards high value APIs.
Sure, and even an example of something like this that we've seen as well, right? Could just be acquiring on the black market large set of credentials, right, and then trying to get in.
Yeah, and especially as you're exposing a lot more consumer data, you probably have consumer accounts, so there's loyalty accounts and so forth. Bots allow those accounts, right? Because now I can go in, automate an attack, and be able to brute force in and get into certain accounts, whether they're loyalty accounts or some kind of consumer accounts that you manage.
Right, which actually is another good point. Back up to the content. Even just your account information, if you have a large user base, that's an interesting target, right? Because this is PIIs, credentials, and other things, right? Even email addresses or phone numbers and that kind of stuff is all fair game and interesting targets for bots, right? And if you're attacked by bots, obviously lots of bad stuff can happen, right? And so if your business, is based on data and they're stealing your data, they're essentially, it's theft of business, right? So an example of this could be, we know some retailers that have kind of price guarantees or, compete on pricing for certain products to bring people into the stores. If your competitors are essentially scraping all that stuff, they essentially can deploy a countermeasured price, against you, right? Or if you've got specialized inventory information, and pricing and inventory is really important in the travel and hospitality industry, right? Pricing is a very important thing that drives kind of customer behavior. People very motivated to go in, get that information, right? Another one we've seen is promotion abuse. So having a specialized product, right, like a limited edition product of some kind, can really attract a lot of attention. And not only just a product, but maybe a service or experience or something like that. Anything that's kind of limited. Limited edition.
And that again goes to if you have limited tickets for a particular event. We have seen retailers with having do-it-yourself workshops, and we have seen bots going after that too.
Absolutely. And so there's a lot of promotion abuse and pricing stealing and those kinds of things that go on. Another thing that happens, as you can see on here, it really messes up a business that's kind of, like I said, data-based. If you're a marketplace type business, and let's say you're funneling leads to partners, all your metrics can be totally screwed up, right? Because in the hospitality industry, in the travel industry, they've talked about this being look to book, right? And your look to book ratio, most look to book ratios are awful. There's just a lot of additional traffic on top of there, right? That's going after those things.
I could also mess up your conversion stats, right?
Yeah. So if you're a leads-based business and your conversion stats look horrible because you've got all this bot traffic on top of the real leads that are converting, and it's really hard to discern. If you're paid, if your business model is anywhere tied to the conversion rate, it can be a real problem. The other point on here, there's a performance overhead that happens, right? We've seen customers that maybe would be 50% over provisioned, right, to kind of handle all the bots. They might be 2x or 3x or 5x over provisioned, depending on what's going on, if there's a special event. And it's all just to handle this huge deluge of traffic that comes in, right?
Yeah, the interesting part is that in the last 5 years, we spent quite a bit of investment to create auto-scale infrastructure, right? For example, we do auto-scale. And so, guess what? The auto-scale is not just for good guys, but also bad guys. Right. So, you're going to have auto-scaling, and potentially, creating, lots of, COGS impact to a business.
Yeah, and on top of the COGS impact though too, there's also an operations fatigue.
Yes.
Right? We talked to a couple customers that said, there's so much bot traffic that comes in, it's also crazy, all the alarms go off and alerts go off, and it's just kind of this constant thing. The operations teams have practically just stopped looking at it. Right? Just because there's so many things going on.
Yeah. So, we can talk about all sorts of use cases, but let's talk about something that happened, right?
Right.
My favorite example here is that what happened to Snapchat last year, where the hackers were able to reverse engineer the private APIs.
Because you don't like Snapchat, or?
Well, the fact of the matter is
just a very public example.
Yeah, I mean, the security industry, we have to be very cautious about giving the right examples. And of course, in the Snapchat's case, the hackers were sophisticated enough to go and look at the API calls. And the interesting part is that they were able to get every single phone number of every 4.6 million users by simply able to match a phone number to an email address, right? Wow. So it's an API that allows you to brute force. Typically you should have something. We'll talk about that, right? You should have some countermeasure like rate limits.
Right.
That should make sure they can slow down the hackers. And this is an example where it's a high reputation situation for a Snapchat or any other industry, right?
Right.
And the reason why I want to bring this example is that APIs, when you expose it, you probably have private APIs and you think they're private, right? And you'll talk more about how hackers are able to get to the private APIs and be able to get access to your private data.
Yeah, absolutely. So there is a huge reputational risk as well. Nobody wants to end up in the news.
Exactly. Yeah.
Right. So let's talk for a minute about what's different about APIs, because web bots have been around for a long time.
Right.
Right. And people are building against APIs for a lot of reasons. Right. I mean, it's they're easy to build on. Time to value is really high. It's, if they're well-designed APIs, and we have lots of webinars that talk about how to design a really great API, it'd be very easy to understand. There's, with Swagger and other things that are happening, it makes it very easy to keep track of changes and that kind of thing.
Mm-hmm.
So, people think of APIs as like this warm, cuddly kitten.
Right.
Right?
Yeah.
It's great, right? So what's the problem?
Yeah. So I think first of all, right, the web world was designed for human to web interaction, right? It's primarily humans sitting behind browsers or sometimes apps, and you're interacting with the web interface, right? Now, what different about API is that it enables both human to machine and machine to machine traffic, right? So when I say machine to machine, is really from an application to your APIs, right? Without really having a human being behind it. So there is a pattern here which is unique to API world, right? Now, APIs are easy to program, right? It democratizes the IT in some way, so you can expose your resources and business logic as APIs, and very easy to program and adapt. The flip side of that is as you know, it's a double-edged sword, right? Because now you make it easy for good guys. So I make I can publish a JSON construct. I can publish the model, the API model.
Yeah.
And it makes it easier also for bad
guys. You mean to tell me there's a dark side to APIs?
For every good side, there's always going to be a dark side, right? So, and we have to be prepared.
That's scary, by the way.
Yeah, I love this picture here.
Yeah, so there is a dark side to the APIs in the sense that because it makes it easier for developers, it makes it easier for all developers, and hackers are developers too.
Exactly.
Right? It makes it very easy for them to programmatically get access to your pricing information, your content, your inventory, user accounts, loyalty accounts, all those kinds of things, right? Programmatically exposed.
Yes.
In a very structured, way with the contract. It doesn't change a whole lot.
Right. Yeah, and in the web world, when your content changed, it may break a bot, right? And they have to go back and adjust it. In the API world, I can easily adapt to the new API by just looking at the Swagger model, or even be able to simply reverse engineer based on what I'm getting from request response.
Right. Okay. So API security is unique then, right? It's different than historical web security, and people have WAFs and other things and stuff like that. Can you maybe talk a little bit about how it's different?
Yeah, and we get this questions very often from our customers, right? They say, hey, you know what? We are pretty familiar with the web security model, right? We have our secure SDLC process. We put a WAF, web application firewall, in front of my application. And again, PCI dictates that you need to have WAF in front of you, so people just go and deploy it. And yes, so those have a role to play because these are OWASP top 10 attacks, very, very common, and you have attacks like SQL injection, right, which is a very common attack, and those apply also to the API world, right? Now the fact of the matter is that there are API threats that are very unique. For example, we know that hackers are decompiling mobile apps, Android, iOS. Mm-hmm. We have MITM, man-in-the-middle proxies that makes it easier to snoop the traffic between apps and APIs, right? When you snoop it, and obviously some of the apps don't have SSL enabled, right? So I can extract the API keys and sometimes OAuth tokens that are more permanent, right? So now we have to think about the kind of attack scenarios are going to be a little more different. A WAF by itself, which is won't be able to defend you, right? And by the way, WAF is designed with known knowns, which means that you are looking at some pre-configured, rules, which are sometimes based on IP address.
Right. So let's talk about how to kind of secure APIs, right? Because we have there's a concept of a value chain, right, that we've talked about a lot with everybody. But you kind of have this idea of, hey, have a layered approach.
Yes.
Right.
Yeah, as a security guy, right, we always want to think about how do you have a layered security.
Yeah. You left yours at home today,
and a white hat. Right?
Okay.
We want to make sure that we look at it as a difference in depth, right? Difference in depth means that you have layers of security, which means both detection, prevention, response, all bundled in. And be able to provide that, for every point of engagement, right? Every point of interaction. So here, you have APIs, for example, that you're exposing to the public or to your internal apps, and you have to make sure that you have sufficient protection for your application that is talking to you. Yeah. So, for example, you'll have a API key-based verification, or an OAuth 2 or JWT in the most recent use cases, that allows the applications to talk to your APIs, right? And of course, they come with things like scope and authorization that you can take advantage of, right? And similarly, from an end user standpoint, if you have to authenticate end users, you may have a requirement to have multi-factor authentication. Google now has two-factor authentication apps and so forth. Yeah. So those are requirements just to have baseline, right? We're talking about baseline requirements, and your APIs, which you're exposing, should be able to make sure that you're not exposing to the entire world. So that's where an API management layer comes into picture, right?
I know a good vendor for that, by the way.
I like the vendor. So an API management layer, will bring in a lot of these features out of the box, like your threat protection, spike arrest policies, right? And these are all built into the product. So I'm a big believer of building an API product with built-in security, right? I mean, anytime you put a bolt-on like a WAF, you're adding another layer of failure and potentially adding latency and so forth. So but it's not even going to help with some of the. Yeah, exactly, right? So
it does its job. It's something else.
Mm-hmm. Right. Yeah. So the key message is that as an API management, as you're exposing APIs, an API management will be able to provide a lot of these features, right. And
kind of all the different layers along.
And these are typically policy-based.
Right. Okay. So then you're good, right? You configure all your security policies and.
Well, that's what everybody else like it here, right? Hey, you know what? I configured my policies. I can go home, have relax with the, and let's see what happens after this, right? So, now once you do configure those policies,
right? But yeah, have a quick poll.
Yes.
Good guy or bad guy?
You know what? Looking at this guy, right, and he's got the right credentials, he's got the right attire, he's got a badge to authenticate himself, right?
Right.
So to me, he looks like a good guy.
Yeah. Obviously, this is the T-1000 from Terminator 2, one of our favorite sci-fi movies. definitely a bad guy, right? And so, yeah, comes from a reputable IP address, has an API key, right? Looks like a good guy, not really.
Not really,
right? Yeah. And so, and this really kind of sets up, hey, what's the issue here is that, across all of your apps and all of your users and all of the endpoints and partners and people that are consuming stuff, essentially, how do you tell, especially when you've got man in the middle or people decompiling apps and things, this guy is, essentially traffic from your Android app, right, coming in, but he might be up to no good.
Exactly, and you can't even distinguish, based on the attributes that person's exhibiting, right?
Right. So being able to discern the good traffic from the bad traffic is really important, and which kind of brings up a larger topic for a second, right? Which is kind of an old model of security, going after known knowns, But I've heard you say many times that hey, that's no longer sufficient.
Right. Again, going back to that, obviously you're going to have certain rules and policies configured that will mitigate certain kind of attacks, right? But in the API world, using a security model that is purely based on known is not going to hold waters or not going to scale, right? And the reason is that, as I mentioned earlier, you're going to have 3 different actors. You got the human beings interacting with the apps. You're going to have good bots, your health bots and performance monitoring bots. Then you got the bad bots, right?
Yeah.
So, let's say the example where, you have traffic coming from a partner and the partner happens to use Amazon, right? Now, I can probably, look at the traffic and say, hey, it's from a partner, right? Now, the fact of the matter is that, that a bad bot could have got access to the partner's key somehow and using, a compromised system out of Amazon and attacking you through, your API keys, right?
It's pretty hard to spin up a machine in Amazon.
It's all API driven.
It's like, it's really easy, right? So, yeah, they can come from there. So, it kind of brings up this issue of, how do you essentially discern the good traffic from the bad traffic, right? And what we've seen with customers is they do a lot of kind of the obvious things, right? And they've got WAF and CDNs, and they're putting in kind of these policies and things like that. And yet, they still have these problems. They still have people coming in and stealing content. Still have people attacking the loyalty accounts, right? Scraping price information. And so it becomes really, really important to be able to do this and do it at scale.
At scale.
Right? Across millions of API calls a day and all these different endpoints and things coming up and down and all this stuff. How do you do that? How do you do that?
And there are a lot of the Fortune 500 enterprises, they have this notion called SOC. It's an operations center for security, right? So you can have lots of human beings sitting behind keyboard, monitoring all sorts of dashboards, and right, and still, right, it's very hard to discern, when you have a bots that emulates good behavior.
Right. Right. So, and that's kind of how we came to the premise that really you need to have a set of rules and algorithms that are looking at all this traffic and being able to discern what's really going on.
Right.
What's reality, right? You don't have to take red pills.
Yes, you don't have to.
But you have to have these algorithms, right? And so we actually have an example of what we're talking about here to give you an idea.
Yeah.
So here's something, and this is a little bit of a tease because we're not saying exactly what's going on, but we're comparing API traffic to something, right? And this is for one of our customers, and clearly there's some outliers that stood out to us. It was like, hey, look, here's a bot.
Right. Yeah. Again, the fundamentally what we're saying here is that using an API data, right, that's coming through a metadata information and the transactions, we can actually discern the outliers in some cases and anomalies. And the only way to do that is, having some intelligent algorithms that sit behind your, the analysis, right? And in this case, as Dave was saying here, that we're analyzing API traffic. In this case, it happens to be a session information, right? By the way, there's the fact that APIs are REST-based. They are stateless by definition, right? So unlike in web world where you track sessions using cookies,
Yeah.
In the API world, you really cannot, use a cookie mechanism, right? Because you don't have a state managed between different API transactions.
Yeah.
So part of the thing is that you have to have algorithms that look at data across and be able to discern what a session is, and then be able to discern from that what a pattern looks like.
Right. This is really one example of actually just one aspect of behavior, right? Of clients coming in for this particular API.
Yeah, and for this particular type of detection mechanism, right? I mean, obviously, it's using the machine learning. But if you're using a known knowns, meaning like you're going to simply use an endpoint attribute like IP address or user agent string, those are not going to, all the bots, will emulate all of that, right? And will be able to still fly under the radar.
Right. So it's really a behavior thing, but there's a challenge even inside of this, right? From a behavior driven approach, is that there's a lot of behaviors.
Yeah.
Right? Maybe you can talk to this a little bit.
Yeah, and
right?
so previous slide we talked a little more abstract here, but let's talk about two use cases, right? One is a bad bot trying to guess a user account's password. This is a brute force attack. So you'll come in, and you're probably seeing a bunch of IP addresses coming in and trying to hack in, right? Using username, password that are harvested somewhere else. It's very easy to buy passwords for cents now. And so that's one kind of attack, right? And the second attack is where you're seeing bots coming in a low and slow and scraping content, pricing information, inventory, right?
Low and slow. Oh, because I have rate limiting policies and those kinds of things already in place. And so they essentially, the reconnaissance bot comes in, figures out where that is, and then just comes in underneath.
Exactly. They know what your threshold is, and they know how to get below the threshold and still go undetected. Now, if you look at this, and simply look and say, hey, you know what? I have a way to block this, right? I can say I'm going to just look at the volume of traffic. Either it's coming from an IP address or a particular region, right? And in both the cases, if I had to aggregate the traffic and say, you will end up with a very similar characteristic, right? The volume is going to look very similar. In one case, you have a spike with a lot of volume for a short period of time, a burst, right? And then kind of taper down. In other cases, you have a consistent volume, right? Now, by purely looking at IP addresses or other attributes and trying to block it based on a volume or size, will not be able to mitigate this threat.
That's why it's really, in doing this, it's really a whole series of rules and algorithms together,
right? To
essentially discern, what is a human and what is a bot,
and be able to look at the context of what the bot is doing, which is the URI, right?
Yeah.
So and WAFs are really good at looking at IP addresses and the rates and stuff like that.
Yeah.
But to put a context, right? The context is it's bot is going after a targeted login URI and trying to brute force, or a bot is going after a bunch of URIs and trying to scrape content. Those are the ones that add value from a learning algorithm standpoint, right? And be able to say, hey, this is a pattern that is specific to a password attack, or this is a pattern that's specific to a content scraper.
Right, absolutely. Okay.
So and that's only two other patterns, right? We have many other patterns.
Yeah, there's a dozen and growing every day.
Yes.
Right? So, and so when we talk about a data-driven approach, that's essentially what we're talking about, right? Is to address these kinds of things. So, what we'll do is we'll show kind of at a high level at least what we're doing in the system what we're talking about, and we can cover this in more depth in a later webcast. But essentially what you're looking at here is a system that is able to collect all the traffic and all the attributes about the traffic, right? All the metadata and everything else, right? And analyze all of that. Apply a set of rules, apply a set of machine learning, to essentially discern, hey, here's real users and real user behavior. Here's bot behavior. Here's some not so great behavior, right? And then surface that up, right? Either in a dashboard or alert or whatever, or if it's something that's even more obvious, pre-configured, and do something about it.
Right.
Right. So it's kind of this closed loop thing.
Yeah. And I think the key thing is that you have to do it in a way that it doesn't impact the performance of APIs. Right, and because of the fact that the data is being collected passively, and analyzed behind the scene, there's no real impact to the APIs, right? And the second point is, you talked about fatigues, right? Yeah, so an operations guy, getting alert every few seconds. So the idea is that you have to manage the exception, right? You don't want to be, managed by fatigue, and getting, then you end up with a lot of false positive situation where you're not able to deal with a real alarm. So a system, the key here is that a system that is automated, in a way it can actually analyze the data behind the scene and be able to apply certain action, right? And we know there are a lot of different actions can be taken. The most common action we have seen is throttling or rate limiting, right? And I think a lot of the folks want to understand how to slow down first to be able to get visibility, right? And the second is to slow them down. And of course, if I have a very specific bot pattern I want to block, for example, I want to block all the login attack patterns, right? I should be able to block it right away because there's no point in letting them go for some time, right?
Yeah.
So you want a system that can identify a bot pattern, be able to take an action automatically, and provide you the visibility through dashboards. And also not necessarily you have to go to a dashboard all the time. You want something that that informs you, and after taking an action.
Yeah, yeah. So how is this different than maybe 10 years ago when you were a young security professional?
Well, obviously, those are the days where the good old firewalls was good enough, right? And you that you can get these folks in through an extranet or point-to-point VPN connections, and it was very much a let's keep the bad guys out by doing a whitelist based approach, right? Let's just allow this 10 guys or 100 guys, right?
Moats and drawbridge.
Moats and drawbridge, right? And now it's all porous and Swiss cheese security model. You got ports opened up like yeah, like your Christmas lights, right? So those models are not applicable to today's API world. And the second thing is again going back to my initial point around protecting against known knowns, right? Known threats.
Yeah. So
now we're seeing a lot of zero-day threats. We see bot patterns that you can't even imagine, right? It may blend in with stealing an API key and be able to take an OAuth token and be able to come in, right? So you have to think about how do you respond to a threat that is being adapted, right? And we cannot build a system that is simply static. It has to be flexible. It has to adapt to threats. Because one of the very interesting quote I heard from a U.S. general is that the cyber criminals are actually getting sophisticated and they are automating the threats, right? So a different system has to be automated.
DevOps for hackers.
Yeah. So
it'll be a new O'Reilly book.
So yes, again, like I said, when you're in a bad case of automating, you better be automated.
Yeah, for sure. Okay, great. And so we wanted to keep this fairly short and snackable. Mm-hmm. And so if you fell asleep for the whole thing and just woke up now, what we discussed is basically if you have valuable data, guaranteed you will be targeted, mm-hmm. right? It's coming. If it's not already happening now, in fact, in some of our customers, we basically told them they were being targeted, right?
Yeah.
It was kind of underneath their nose.
Right. And again, just emphasize, sometimes you may believe that you are securing it through private APIs. And in this game, it's open season. This is private APIs, public APIs, right? So you are a target irrespective. Yeah.
Private's no longer necessarily private.
Yeah.
Right? And we talked about how APIs are unique, right? It's a unique challenge, and that kind of old approaches. What got you to today is not going to get you to where you're going tomorrow, right? And you've got to talk about the layered security approach and that kind of thing. And we ended up with there's the only way to really discern in a scalable way the real traffic from bot traffic is with a kind of combination of rules and machine learning type approach, essentially data-driven security approach.
Exactly.
Right. And finally, we kind of gave you a teaser as to this automated system that we've been building, right, to capture, analyze, report in the information, and then act, right?
Mm-hmm. Yeah. I mean, end of the day, you have to have a system that scales with your traffic, as well as scales with the type of APIs that you're exposing.
Yeah, absolutely. And that's pretty much what we wanted to share today. Cy, the marketing guy, wanted us to show this slide, but we're not going to talk about it. But I don't know if there's been any questions, but we can take a few questions before we shut down the webcast.
Yeah, so we have some questions here.
Already got questions? Okay.
Yeah, oh, great. All right, the very first question is, what does the latency introduce between the actual event happening and corrective action happening taken?
Oh yeah, great question. Yeah, absolutely. You want to?
Yeah, so certainly, so one of the key design tenets for us is that the analysis and enforcement, should be in a way almost close to real time, right? First of all, there's no impact to the API traffic, right? So irrespective of
performance impact of traffic coming through.
Yeah, there's no impact, right? And now, in terms of
and the reason for that is because it's all out of band analysis.
It's all out of band, and the systems that are processing are independent of the system that are processing APIs.
Yeah.
Right. So they are, it's dedicated for analytics.
Right.
And in terms of the actual, the latency between when we detect versus enforcement is almost close to real time, right? And the fact of the matter is that our platform has distributed cache mechanism, and typically, these are all, we're talking about milliseconds, right? Mm-hmm. So if we enforce an action, say US East, and within milliseconds US West, right? So we're talking about close to real time here.
But you're not really answering the question.
Mm-hmm.
I'm just kidding. So, but to be direct, so the design bar that we've set for ourselves right now is 5 minutes or less, and we're actually already kind of beating that, right? So if the traffic's coming through, it does take us a couple minutes to essentially ingest all that traffic, kind of normalize some things, analyze it, right? If it's a totally new bot, right? Yeah. That we need to discern and say, oh, hey, look, this thing just violated, 6 algorithms that we have. Mm-hmm. And we're going to surface that up, and based on what we set, if it violates these 6 algorithms, shut this guy down, especially if he's going after this endpoint. Yeah. That brand new loop is a 5 minutes or less kind of a thing. Now, if we've seen him before, right? If we've actually seen that guy do that kind of thing before,
right?
It's
so yes. So that there are going to be certain patterns that we have memory, right? And we know exactly the kind of behavior that was exhibited by bad bot, right? Yeah. So those are going to be, right away you're going to catch it, and obviously there is going to be certain kind of bots we may take, a few iterations before we know that it's actually a bot, right? Yeah. So the answer is going to be, it depends, right? But
this is actually a fantastic question, right? Because there's 2 ends to the spectrum, right? On one end of the spectrum is somebody who comes in really low and slow and is just trying to grab a little content here and there. It might actually take some time to discern that this guy's a bad bot, mm-hmm. right? On the other end of the spectrum, you've got things that come in, and let's say you've got a limited time promotion, like a limited edition product that comes in. That's like flash sale type thing, right? Right. Star Wars tickets are gone in 2 hours, right? That. So you really are looking at 5 minute slices of time or less to quickly discern, hey, who's misbehaving?
Yes.
And feed that in.
Yes. Yeah, and that's why I think you have to put the context of looking at what the bot pattern is, right? Which is like if you have an attack on a flash sale, ticket flash sales, so we know exactly what the pattern looks like, and we can block it in less than 5 minute time. As soon as we can analyze and enforce action. Okay, go ahead.
Yeah, what is Apigee's take on OAuth to password grant type? Do they rely on connecting to the password grant service of the authorization server, or does Apigee have a way to maintain a user repository in Apigee itself so the password grant is validated? That's definitely a question for you.
Yeah, by the way, this sounds like a more of API security question than a bot.
That's fine.
Question, right? So, so Apigee, we support all 4 grant types. If you're using us for password grant, obviously, we can mediate. We can take the user ID password and mediate with your INT provider and auth service provider. and be able to then at that point get the OAuth token, and we will issue the OAuth token to the caller, right? So from that point, the caller will be using the OAuth token in the header, so we can validate it for further API request. Now, as far as if you want us to hold, we have two options, right? One is we can go to a IDP that you have username and password, or we also, if you're using our BAS, you can actually host a set of users and passwords, and these are all stored in a secure fashion. And we can issue an OAuth all the way. So we can act as a OAuth provider, as in terms of authentication, as well as user as well as ID provider, right? So we provide an end-to-end service if we end up hosting the usernames and passwords.
Awesome. Next one. In Apigee Developer Portal, is it possible to have some of the smart docs be private and others be public?
I have to defer this question to we can get back to you. Obviously, the developer portal, it depends on how you architect it. Every customer has unique requirements for developer portal. Some of the
so we're not really sure we can get back to them on that, but I think there's a larger question of how much is that going to help? Right? I mean, it may be thinking about that from a different perspective, but they may slow down a developer, but they still can go after private APIs.
Right.
Right?
Yeah, it's a good point, right? So if you're trying to hide the APIs by just hiding the API docs, it may not do much good, because hackers can go after your app directly and be able to understand what the protocol looks like and the handshake and so forth.
I'm certain that you can do access control on API docs and consoles and things like that. I know we've done that all in the past, and so you'd be making, that might be almost, you might think of that as security theater, right? Essentially, hey, we think it's secure and it's private, but it can end up really not being that secure and private.
Right.
Here's another one. Are these machine learning algorithms to identify malicious traffic part of Apigee Sense, or do we have to define our own ML algorithms?
Yeah, certainly these are part of our our stack, so to speak. So we bring in a bunch of algorithms that are built into the platform. Today we don't have the option to bring your own algorithm, right?
Yeah. So the where we're headed on this. So the answer is yes. There's a set of algorithms, and we've spent a bunch of time building a bunch of different algorithms, looking at traffic patterns across a bunch of customers, and so that all comes with Sense. What you're referring to is, we also recognize that for specific APIs or certain customers or API product bundles, our customers may want to also enhance or tweak those a little bit, right? And so we're also working on ways to,
so we can certainly provide, we'll be providing configuration by which you can, for example, you may be able to shift certain type of patterns that are more interesting to you, because every patterns are unique to the kind of verticals they come from, right? So you'll have flexibility to, give input into the algorithms. But today we are not. It's not a pluggable ML model, right? So it's all built into. We want to make sure that
it's built in today, and so you get a package of algorithms that we've been working on for quite some time now, and then tomorrow, those will be configurable, right? Where you can essentially customize those based on your particular set of APIs, that kind of thing, right? I think that's all the questions. Are there any other questions? I think that's it.
I think that's it.
Okay, great. So appreciate you guys spending time with us today on this. We will have another edition of the webinar. In the future, we'll go more into detail about Apigee Sense and how we built it and some of the algorithms and things like that.
Right. Yeah, we'll talk about the under the hood a little more deeper, and and if any folks are interested to talk earlier this. Right?
They can get a hold of me. I think my Twitter address was on the front, or you can just send me an email, David@Apigee. Great. Thank you.